66. Which of the following statements are true? So we know that this gallium will have low melting point, okay, which when you keep in hand it melts in the summer and get little waxy during winter, and gallium will have a melting point around only 30 degrees Celsius. So it is very clear that they don't have a melting point, high melting point than the cesium, because cesium is more ionic and their melting and boiling points will be much higher. Okay, so the first option is wrong. On Pauling scale, the electronegativity values of nitrogen and chlorines are not same. Of course, this is right. They don't have the same electronegative values. And when you go for all isoelectronic species which have 18 electrons, if you check, all of them are right. Okay, argon 18 and sodium 19 minus 1 18, chlorine 17 plus 1 18, and calcium 20 minus 2 18, and sulfur 16 plus 2 18. So all are equal to containing 18 electrons and is said to be isoelectronic. The correct order of first ionization enthalpy, here a particular order is given, and we know that magnesium is completely filled and have the first ionization energy really big than your aluminium. So silicon comes first, then comes your magnesium, then your aluminium, and last is your sodium. So here the order is wrong, so I cannot take. Then atomic radius of cesium is greater than that of lithium and rubidium. Of course, this is lithium. Below that you have a sodium, potassium, rubidium, cesium. Then comes francium. When you move down the group, atomic radii will increases. So this is the right option. So I can take B, C and E to be right, but we don't have a such option here, B, C, D. Instead I can take C and E, the right option. 67. So this is regarding geometry from chemical bonding unit. Okay, so here we have a xenon, double bond O, double bond O, double bond O, and here we have a lone pair, and here xenon we have a 3 lone pairs from here and fluorine above, and here xenon with 1 double bond O and 4 fluorine present in a square planar form like this, and we have a 1 lone pair here. And the last one is xenon. We have distorted octahedral because of the presence of lone pair, here. Okay, so we get a distorted form. So XeF6, which have 1 lone pair and 6 bond pair, will have a distorted octahedral. And here you have XeF2, very easy to identify. That is XeF2. It has a linear in its shape. Okay, then we have XeO3 with 1 lone pair and 3 bond pair, and that is going to be pyramidal, and XeOF4 is going to have square pyramid. So such options we have, that is A, pyramidal A comes here, pyramidal A2, B1, okay, then comes C, C4, A2, B1, C4, and D3. So you can find option 4 as a correct option. And 68th question. So 68th question, it is from thermodynamics. Okay, thermodynamics, all data were given the formation of SO4 2 minus, and here you have a formation of BaSO4. Okay, here the standard formation of BaSO4 is also given very clearly. We need to find out the heat of formation of barium 2 plus ion from barium solid. Let us write the equation first. Okay, so I am taking sulfur plus oxygen. 2 oxygen gives you the formation of SO4 2 minus, as delta H1 is equal to minus 216 kilocalories per mole. Okay, kilocalories per mole inverse. And similarly I can take barium, okay, 2 plus SO4 2 minus gives you barium sulfate, then delta H2 for this is minus 4.5 kilocalories per mole. And the last equation is barium solid combines with the sulfur and 2O2 leading to the formation of BaSO4, and the respective enthalpy change is delta H3 minus 349 kilocalories per mole. Okay, we need to find the standard heat of formation of barium 2 plus ion aqueous. So from the solid to the conversion of Ba2 plus aqueous we need. So on solving all these 3 equations, we have to bring the 4th equation. So let us assume this one as 1 and 2 and 3, and this is 4, what we need. Okay, so to get the 4th equation, what I am going to do is I have to reverse this 1 and 2. I have to reverse this 1 and 2. So I'll be getting sulfate 2 minus, that gives you sulfur plus 2O2, and hence I'm also changing the sign of this delta H1 value, which is going to be plus 216. And next is BaSO4 again I'm reversing, Ba2 plus and SO4 2 minus. Here we can take delta H2 value as plus 4.2 kilocalories per mole, and your last equation is Ba plus S plus 2O2, which gives you BaSO4, and that is going to be delta H3, that is minus 349. So when you solve this, you can find BaSO4. When you add all the three, and SO4 2 minus SO4 2 minus getting cancelled, sulfur, oxygen. So what is the left here? Ba solid gets converted to Ba2 plus aqueous. Here aqueous. Okay, how I get this fourth equation here? Adding all the three. So what I am going to get, delta H value, the total delta enthalpy change can be taken as delta H3 plus delta H2 plus delta H1. Now when you substitute these value, minus 349 plus 216 plus 4.5, you will be getting the answer minus 128.5. So the correct option would be fourth one. 69th question, among the given compounds, okay, the character of bond dissociation energy of CH bond marked with asterisk mark. So here you can find the three structures with carbon containing asterisk mark. So we are going to do, what happens when the bond between these carbon and hydrogen get dissociated? When it dissociated and gives you the stable ion, then it easily goes and have the bond energy lower. But if you look at the third structure, which is found to be anti-aromatic in nature, this anti-aromatic nature is actually not, considered to be stable compared to aromatic and non-resonating structures. Okay, non-aromatic. And this aromatic, if I consider children, you can find ion stability is least. When you break this ion, you will have a carbon minus here. When hydrogen is considered to be H plus here, then carbon will be minus. Bond dissociation energy of this CH bond is maximum, because if it lose H plus, it attains anti-aromatic nature like this, negative in the carbon. You have 4 pi electrons which attains anti-aromatic, which is stable state. So they don't prefer at all to leave this H plus immediately. So the energy required to break such a bond is higher. Okay, so the third structure don't want to attain the anti-aromatic, which is the least stable state, so they don't never try to break this bond. So you need to give more energy to break the bond. So I take this third option to be highest bond dissociation energy involved. So the one and only option here is option 2, where the third option is maximum. Then comes second and first. Predict the major product in the following sequence of reaction. So when you consider the given structure, 3 reagents are given. Okay, the question from hydrocarbon. Okay, whenever benzyl peroxide present, it follows anti-aromatic rule. So this negative part will move to the carbon containing more number of hydrogens. More number of hydrogen in the sense, consider these two carbons. If I shift bond like this carbon will have a negative and this carbon will have a positive. So this bromine negative part goes to the carbon containing more number of hydrogen. Here we have one hydrogen and here we don't have hydrogen. So our shifting is right and Br minus goes to this. As a result, we have a compound CH3 Br attached to here. And what about when you go for Cation addition, then nucleophilic substitution reaction will be carried out. We have C triple bond N substituted here. Again, when you go for the addition of reducing agent like sodium amalgam in an alcoholic medium, we have the addition of hydrogen on both sides. As a result, we have a pentane with a methyl group here and CH2NH2, formation of a primary amine. So the correct option here is fourth one. Our next question is 71. Match the following. Ziegler-Natta catalyst is an important catalyst which is used in polymerization, and it is TCl4 with trimethyl aluminium. Wilkinson catalyst, from coordination compounds we know that it is nothing but a rhodium complex, and Wacker process we use palladium chloride, and for Haber process we use iron as a catalyst. So they are very straight to the list too, and the correct option here is A1, B2, C3 and D4, which is second option. And next one is from atomic structure unit, 72nd question. Energy and the radius of first Bohr orbit of lithium helium and lithium were asked. So what is the formula? We know that, okay, you're being okay, here n is equal to 1 first orbit they are asking. So I can write, okay, minus 2.18 into 10 to the power minus 18 into n square by z square. So sorry, z square by n square. So z square for if I go with the helium, okay, its atomic number z is equal to 2. So I can take 4 z square, which is equal to minus 2.18 into 10 to the power minus 18. Z square here becomes 4. So when you multiply this, you will be getting the answer around minus 8.7 into 10 to the power minus 18. Similarly, when you go for lithium plus 2, okay, so where n equal to 1 here also, so 1.1. So this 2.18 into 10 to the power minus 18 into the same z square by n. And what about atomic number for lithium? It is 3. So 3 square is going to be 9. You will be getting answer around minus 19.6 into 10 to the power minus 18, and both are in joule. And in the case of calculating the radius, Rn is equal to R naught into, we know that it is Rn and square by z. So applying this for helium plus 1 and lithium plus 2, I can write R1 is equal to 52.9 picometer radii into 1 divided by 2. And what about here? R2 is equal to 52.9 into 1 divided by 3. Okay, so the here correct option for radius, if you calculate, you will be getting 17.6, and here you will be getting 26.4 something. So I can go with the option. Okay, check option 4. So option 4, I have lithium plus 2, okay, with the values minus 19.6, okay, and what about radius? It is 17.5. Then helium energy is 8.7, and for radius it is 26.4. So the correct option is 4th. 73rd question. Given below are two statements. So assertion A, okay, so here 1, 2, 3, 4. Butyl iodide undergoes SN2 reaction faster than butyl chloride, and iodine is a better leaving group because of its larger size. So if you check here, children, iodine, we all know it is a better leaving group because Ci bond is very weaker and easy to break because it has a greater bond length. When you go for bond length, Ci will be greater than Cbr, than CCl, than Cf. So bond easily breaks carbon and iodine, and it undergoes nucleophilic substitution much faster than the chloro compounds. So both option A and R are true. Or is the correct explanation of A. 74 is calculation of time required for the completion of 99.9% of reactions, and half life is given here, which is nothing but 1 minute. We know the relation, very direct relation, that T 99.9% is equal to 10 times the T 50%, that is half life. So I can directly put 10 into 1 is equal to 10 minutes. So here 10 minutes is the answer. 75th question. Which of the following aqueous solution will exhibit a highest boiling point? So for calculating this highest boiling point, children, let us take the relation T delta B, that is elevation in boiling point, is equal to TBS minus TB naught is equal to I into KB into M. Calculate when I increases, okay, when I increases, delta TB increases, and automatically the boiling point of solution also increases. Here they are asking the highest boiling point of the solution, aqueous solution. Let us check for option 1. For KNO3, I factor is I equal to 2, and for Na2SO4, so I factor is simply 3, and for glucose I factor is 1, and for urea NH2 twice CO, okay, the I factor is 1. So this Na2SO4 has a higher I factor, and its solution will have the highest boiling point, so option 2. 76th question. Higher yield of NO in N2 plus oxygen, which is in equilibrium with 2NO, can be obtained at, this seems to be endothermic reaction. So for a endothermic reaction, when you increase the temperature, then reaction moves forward. Okay. Similarly, for whenever in general, when you increase the concentration of your reactions, it moves towards forward. Okay, so and for this A, higher temperature and higher concentration of N2, higher concentration of O2 favors the forward reaction, that is a formation of 2NO. Okay, and here the correct option is ACD. That is option 3. Match the following. 77th question. It's such a direct question from practical chemistry. We know that Pb2 plus comes under, okay, Pb2 plus comes under group, and Al plus 3 group 3, and cobalt comes under group 4, and magnesium comes under group 6. Here the correct option would be, okay, check here first one. So A go for 3 and B go for 4. B go for fourth option and C for first one and D for second one. Okay, so the correct option is A. The next question is, this is also from atomic structure. That is the ratio of wavelength of the light absorbed by the hydrogen atom when it undergoes two transitions, N equal to 2 to 3 and 4 to 6. So let us consider 1 by lambda is equal to RH into 1 by n1 square minus 1 by n2 square. If you substitute these transition in the equation, we get, let us take the first transition as lambda 1, and that is equal to RH. So when you substitute here, instead of n1 as 2 square and instead of n2 as 3 square, you will be having RH 1 by 4 minus 1 by 9. So when you solve this, you will have lambda 1 is equal to RH, RH 5 by 36. Similarly, when you solve for lambda 2, that is RH into 1 by 4 square minus 1 by 6 square, you will be getting lambda 1 by lambda 2 is equal to RH, that is RH into 5 by 144. Okay, if I take a ratio of these two, you will be getting, that is lambda 1 by lambda 2, you will get the value 1 by 4. So the correct option here is third one. 79th question, the correct order of the wavelength of light absorbed by the following complex. So when the strength of ligand increases, energy absorption increases. We know that energy is inversely proportional to, okay, Hc by lambda, inversely proportional to your energy. So when energy increases, then its wavelength will decreases. Okay. So when you take, they are asking for wavelength of light absorbed by the following complex. Here Cn is the stronger ligand than your ammonia, okay, than your water. So this B will have the maximum energy, okay, but minimum wavelength. And after that you have ammonia, A will have the next level of energy but have the wavelength lower. And then comes here B, A, these two options are present in first one. Okay, then comes D, then comes C. Okay, tetrahedral, being a tetrahedral, it will have the maximum wavelength, minimum energy, and its strength is also less. Question number 80, identify the correct orders against the property mentioned. Okay, we know that dipole order, okay, the dipole, because of a strong hydrogen bonding, the dipole of this H2O is much higher than ammonia. So the option 1 is right. Okay, and when you go for second one, you can find the lone pairs present in the xenon, tetrafluoride and oxide and difluoride. So here we have 2 lone pairs of electrons, and here we have 1 lone pair, and here we have 3 lone pair. So they arranged the order in a lone pair present. Actually XeF2 should be greater than XeF4, then least will be XeO3. So this order is wrong. And regarding bond length, we know that PP overlapping bonds have more bond length than SP or PS. Here N and oxygen, nitrogen and oxygen will have a PP overlapping, and hence its bond length should be higher. So order should be NO must be higher than CH than your OH. So this order is also wrong. And bond enthalpy, of course, N we have a triple bond, oxygen we have a double bond, and hydrogen we have a single bond. So bond enthalpy order is right. Here A and D are the right option, so it should be fourth. 81st question, match the following. So it's also a direct question from purification of organic chemistry. Okay, so CHCl3, chloroform and aniline can be separated by simple distillation, and crude oil, of course, we all know it is from fractional distillation, and glycerol from spent life, it is from distillation under reduced pressure, and aniline water goes for steam distillation. Okay, let us check the fourth option here. So A goes to 4, list 2, and B goes to third one, and C goes to first one, and D goes to second one. Okay, D goes to second one. So option 4 is right. If the rate constant of the reaction is 0.03, how much time does it require to take 7.2 mole per liter concentration of reactant to get reduced to 0.9 mole per liter? So what is the formula? So based on that rate constant, which is second inverse, it is a first order reaction. So let us write the formula for this. T is equal to 2.303 divided by 0.03 into log final concentration divided by initial concentration, and you will be having 2.303 by 0.03 log 8, and the value of log 8 is around 0.9. So when you solve them, you will be getting 69.3. Okay, so the correct option is fourth option. Next question is question number 83. Which among the following electronic configuration belongs to main group? First, you should understand what is a main group. S and P block elements are said to be main group elements. Let us check. The last differentiating electrons enters into S orbital, and hence this belongs to S block element. And here it is 3d3 4s2. So the partition of electron tells you that they are from D block element. And here you can find P orbital involving. So this is going to be P block element. And here again D10 4s1, which is nothing but our copper from D block element. And the last one is actually F orbital is involving here. So here the last one will be F block elements. So they are asking for S and P block elements. So the correct option would be A and D. And here I can take P orbital, of course, P, A, C, D, which is option 3. 84th question, and this is types of solutions. So alloys, we know that it is solid in solid. Okay, smoke, we know that it is in solid in gas, and humidity liquid in gas, and amalgams are liquid in solid. So the correct option, let us check. So 1A goes to second options, and B goes to first one. Okay, and amalgam goes to fourth one, and D goes to third one. So option 1 is right. So 85th question, 5 moles of liquid, okay, 5 moles of liquid X and 10 moles of liquid Y make a solution having a vapor pressure 70 torr. Okay, so the total pressure, vapor pressure is given as 70 torr, and their pure X and Y vapor pressures are given as 63 and 78. Okay, using a Raoult's law, let us write PT is equal to PA, or here I can write PX naught and XX plus PY naught into XY. So Px naught is 63 into mole fractions, number of moles of solute is 5 here, and total is 10 plus 5, 15. And here Py naught, it is 78 into 10 divided by 15. So when you solve that, you will have answer around 73. Okay, here you can find the calculated vapor pressure is much greater than your observed vapor pressure, and hence the vapor pressure get decreased and shows negative deviation. So the correct answer here would be first one. So this is energy profile diagram from chemical kinetics, where you can find in general, if it is exothermic reaction, the curve is like this. If it is endothermic reaction, okay, the curve is like this, isn't it? The curve is like this, right? So here they are asking for exothermic reaction, children. So graph should be in the first model. So we can find two graphs, option 2 and option 4, to be similar. Among that, delta H actually represents, we all know that delta H is equal to EAF minus EAB, which is said to be negative here. Okay, so here this is said to be EA, energy of activation of forward, and this is said to be energy of activation of backward. So EAB must be greater than EAF so that you will get a negative value. So the suitable graph for this particular concept is 4th. 87th question, the following compound that does not decolorise bromine. If you take a phenol and add a bromine water, you will get a tribromophenol. Okay, tribromophenol. Okay, 2 bromine in ortho position and 1 bromine in the para position. And if you go for a styrene, okay, styrene, they decolorize, giving rise you the addition reaction, that is Br2 H2O, where here 1 bromine and here another bromine added. And in case of aniline, when you add a bromine water, you will get tribromination, that is Br in 2 ortho positions, okay, and 1 OH here, NH2 and 1 B here. So all these 3 will decolorize a bromine water, but the cyclohexane, which will not undergo any reactions with the bromine water and does not show any decolorization. So here the correct option is 4th. 88. We need to calculate the oxidation state of central atom present in 3 compounds, that is they underlined here. So potassium always have a +1. So this is a superoxides where it exists in +1 state. This hydrogen peroxide, we know that the central atom is oxygen here. When you take oxygen, you have a 2 minus. When you consider the charge of one oxygen, you will be having minus 1. Okay, so here the oxygen will have a minus 1. What about sulfur? Here we have a plus 6. And you know how to calculate the oxidation state of a sulfur, that is 2 into 1 plus x plus 4 into minus 2, that is equal to 0. So when you solve this, you will have a x is equal to plus 6. So the correct option is plus 1, minus 1, plus 6, fourth option. 89th question. Given below are two statements. Statement 1, benzene diazonium salt is prepared by the reaction of aniline with a nitrous acid and at 0 to 5 degrees Celsius, and it is given 273 to 278 Kelvin. It decomposes easily in dry state. So here you can find the preparation of benzene diazonium chloride in most of the question from aniline and nitrous acid, isn't it? So aniline NH2C6H5NH2 plus HNO2, okay, 0 to 5 degrees Celsius, you will have the formation of benzene diazonium chloride. Okay, and in statement 2, so this statement 1 is right. Statement 2, insertion of iodine into benzene ring is difficult, and hence iodobenzene is prepared through reaction of benzene diazonium salt with Ki. So when you take benzene diazonium salt with Ki, you can find the formation of iodobenzene with the N2 gas released and KCl formation. So both the statements are correct. So both the statement 1 and statement 2 are correct. 90th questions, which of the following are paramagnetic? So when you solve these questions, you can find the central atom and its oxidation state and how many electrons remained in each. So when you take here, nickel will exist in +2 state, and hence it will have outer electronic configuration 3d8 and 4s0. So chlorine is a weak ligand and no pairing occurs, so totally we have 2 unpaired electrons. When you go for the complex tetracarbonyl nickel, where nickel exists in 0 oxidation state and 3d8 4s2 will be its outer electronic configuration. Carbonyl CO group being a strong ligand, these two electrons get paired up with 3d8. Now it becomes 3d10 4s0. So no unpaired electron, 0 unpaired electron presence. When you go for option C, okay, where nickel exists in +2 oxidation state, where it has a 3d8 4s0. Okay, when you check the ligand strength, cyano is a strong ligand, so all the d8 electrons will get paired up, okay, and you will have no unpaired electrons, that is 0. Okay, and when you go for option D, where nickel exists in +2 state with 3d8 4s0, and water here acts as a weak ligand, so no pairing occurs, still you have 2 unpaired electrons. And the last option is PPH3, triphenylphosphine, as a ligand which is a neutral ligand and such a strong ligand here. Okay, because of strong ligand where nickel exists in +2 state here, okay, pairing occurs. So all are completely paired and diamagnetic and 0 unpaired electrons. So totally we have option A and option D, which possess 2 unpaired electrons in each. So the correct option would be A and D.